Hello, hi Francis. Welcome everyone, right? Who is joining up here, right? For this workshop for the ICP hackathon that we are organizing. So I'll be sharing the details of the hackathon in the chat box, right? So you can guys can whoever is joining up, who haven't registered for our hackathon, can join in from that link. Uh, I would like to welcome here Francis, right? Who will be our developer mentor here, right? And who will be guiding all the developers how to start development on the ICP blockchain. Right? So, welcome, Francis.
Hi everyone. Good evening, everyone. Um, I believe all of you already know how to code some basic smart contract, whatever, to deploy your canister into ICP, right?
Yeah. So,
Okay.
Francis, like structure this in a way like a basic introduction about IC and then the development part. I think that is the best way out for doing this.
Oh, okay. Then that means I need to uh, open some of my slide that
Yeah.
for
Yeah,
previous
please.
previous wait
Yeah, absolutely.
I will go through some previous slide first.
Yeah, please.
Then I will share. Let me open. Um, Okay.
So for the people who are joining here for our workshop, right? Who haven't registered, right? So to link to register for this hackathon is pinned here in the chat box, right? So in the meantime, if somebody is not able to have registered till here, you can do that, right?
Okay. Let me share my slide.
Yeah.
Okay. Yeah. Window. Right. I only can share. Share. Link. Okay. Share.
And with the screen sharing, Francis?
Yeah, I'm creating the screen share. Yeah, I'm opening the slide.
Oh, sure, sure, please.
Okay. Okay. Share. Okay. Can you see all the slide?
Yes, I can see that now. Yeah, please.
Okay. So to start with, for those who never did any development with ICP before, so let me have some introductions about the ICP. So ICP is more focused on decentralized cloud, more focused on decentralized cloud. Basically, it has a very good features, especially compared to other blockchain. Even you can deploy your full stack application. That means full stack application into ICP cloud compared to other blockchain. Means you can run your backend smart contract. You can run your full website or even you can run your AI, all this into ICP blockchain. So here is some of the prerequisite if you want to start to do your development. So this is another slide. Later I'll share you this another slide. Basically today I got 2 slides. So so this is more basic one. So this is some of the prerequisite that you need to have if you are using Windows 10. If you are using Windows 10, please please install WSL, Windows Subsystem Linux, because all the SDK, right? All the ICP SDK development tools only able to run in Linux environment. So if for Windows, you without WSL, you cannot install the tools. So in this slide, actually, I will provide you some of the step by step. Let me share another slide into the groups. So you were able to see. Okay. So then I also prepare some of the sample code for you all to test it out. So by default, I believe, so all of you join this workshop is a developer. I believe all of you already have a GitHub account. For those who don't have GitHub account, please please create a GitHub account. Then from your under your GitHub account, this is the first sample code. This is the first sample code I prepare for you. Later on, there will be certain step how you create a developer account or ICP account. So what is shared actually is another sample code. So there's another copy I paste in the, let me paste in the chat. Let me put into the Telegram groups. Okay. Let's see. Okay, I already put the link in the Telegram group. So who haven't joined the Telegram group, please join the Telegram groups. So these are one of the basic sample code. What you need to do is just fork. You just fork my sample code. Then this is a step to fork. Okay, after once you have the sample code, then in your laptop, please prepare your under. This is only for Windows devices. If you are using Mac OS, you can skip this step. So please, if for those who are using Windows, please open your command prompt. Then you run this WSL -- install. So it will install a Windows Subsystem Linux. After that, please continue another step, install the Ubuntu Linux by default. So this is some of the steps you need to prepare. So once it will take some time because this installation will take about 10 minutes or something because it required to download about 200-300 megs of files to do the installation. Once you have the environment ready, then the next one you need to also have a Node.js. Node.js installed inside the Ubuntu. So you need to follow this step. To install the Node.js. So the first step is install the Node version manager. Then you use the NVM to install the Node.js application, which minimum version is version 20 on and above. You can install 22, you can install 24. It's okay. So once you have Node.js installed, the next one, yes. So you need to copy the command line. To install the Internet Computer SDK. Let me see. I think you don't have this slide. I will share this slide into the Telegram groups again. So you can open this slide and go to this tab and just copy the command line. from the ashes, all this, it will do the installation, the SDK installation. After that, so after that, you will need another one tools. It's called Motoko Package Manager. So there were several steps you need to do those relevant installation. So Motoko Package Manager is basically is something like npm. If you're using Node.js, all this, when you want to install external or third-party package, third-party library, normally you run npm space I to install that. Yes, Motoko also is a smart contract. It's a smart contract default or native smart contract of ICP blockchain. So there is a lot of a third-party user develop a server package. So you can use this to do the installation, to install the external package. And after that, once you have this, for those, because sometimes if your laptop didn't enable the virtualization technology, the VT technology, if you are using Intel or AMD in your laptop or your device, hasn't enabled the virtualization technology, you may face some issue when you install WSL. When you install WSL, it may not able to run, or even you didn't update your Windows to the latest update. Yes, it will you may have some issue during installation. Then I actually also provide you another option whereby you can install, actually you can install the you are not installed. Basically, I give you this link. You can use Gitpod. You can use Gitpod to create a temporary virtual machine with all the environment ready for you for temporary. So those are the installation step. Okay, the next. So the next one is, the first step is to how you create your developer account or ICP account, or you can say this is a wallet. So this is ICP account compared to other blockchain. So it's the same. It will also using public private key pair for authentication. Public private key pair for authentication. And like compared to others blockchain like EVM, all these, you have a wallet address, all this. Normally, like Bitcoin, we also call wallet address. In ICP, once you generate the public private key pair, there will be a first type of identifier. It will call principal ID. In ICP, got two type of identifier, two type of format for one private public key pair. There will be a principal ID, and it also have another identifier called account ID. So you see the principal ID, and it's called account ID. So for account ID, the purpose of having account ID, it is used to store the or whole ICP token. So that means whenever you want to send or receive ICP token, you must tell the other party your account ID so that they can send the ICP token to your account, not principal ID. Principal ID, it is used for the ownership of canister. Later, I will explain what is canister. So it will use for the ownership of canister. It work like the user ID, something like a user ID within your Windows operating system. In your operating system or Linux operating system, there is you can create a lot of user, right? Or there will be administrator user, normal user. All the user has a user ID. Yes, principal ID is to use to determine the ownership of the canister or the application run inside the ICP blockchain. So how you create your first ICP wallet or developer account. So after you have all the tools running, install, then you can run this. You can run this DFX identity new, and you enter the account name or identity name, any name that you like and easy to remember. So once you type DFX identity new, you enter, it will return you 24 seed phrase, 24 seed phrase, 24 words of seed phrase. Same like others, how you generate the modern wallet, which they will always give you a seed phrase or mnemonic words. So this is your private key. Remember to back up your 24 words, because in future, if change device, all this, you are required to use this 24 seed phrase to recover back your account. So this is how you generate the identity. Next. Then once you have the account generated, then you can use get principal. You can use get principal to retrieve your principal ID. So the principal ID is look like this. Principal ID is look like this. Then you can actually generate multiple account in your device. So once you have multiple account in your device, because when the moment you use the new different label identity name, then you can use this command line DFX identity used to change your account, change your current active account. Then you use get principal to retrieve the principal ID. So now you have your principal ID. So after that, how to get your ledger account ID? It's the same. It's just different command line, ledger account ID. So once you have this, type this command line, you will get your ledger account ID. So as I said before, this account ID is used to hold your ICP token, and it is only used for holding ICP token. Means for you want to receive ICP token from someone, please do share this account ID, not principal ID. But if you want to receive non-native token, means non-ICP token, means it, because in ICP, same like Ethereum, all this, you can create your own token, deploy your own token. So in ICP default, you already have a bridge version or digital twin version of BTC, like CKBTC, like CKETH, CKUSDC, or even your own token, because you can use the smart contract to create your token, and all the ownership or receiving those type of token, you need to use principal ID. You need to use principal ID. That means you want to receive CKETH, you are not giving account ID to other party to send to you. You need to give principal ID. You need to give them principal ID so that they can send you CKETH, CKUSDC, or CKBTC, or any of the token. Account ID only for you to receive ICP token. Okay, so hopefully you get this. So this is some of the basic how you create your first account using command line. Then the next one, as I already shared the my sample code. Already share my sample code. Then you can fork my code. Just like I asked you to fork my code, right? So once you're able to install that, so please do go edit this sample code. You paste your own principal ID and paste your account ID and commit it, so that I know that you already success complete the first step, which you have your own, you already successfully generate your ICP account, and you're able to get your principal ID and account ID. So you commit it, done. Okay, this is how you recover back your account. in case you change device. In case you change device, then you follow the same step, install all the relevant tools. Then you need to run DFX identity, import space dash dash sig dash file. Then you create a text file, you paste in back your 24 seed phrase. You paste in back 24 seed phrase in the text file. Then you save it. Then you use this command line to recover back your account. So there's some of the command line. There is this other command line. I think it's more basic. How you retrieve your ICP token inside your account ID. So other for end user. So when you do development for end user, because just now the way you create account is for developer, means you want to use that to deploy your application, to develop your application. That is the method. But for end user, they won't use this method. So for end user in ICP, most common use method is a web wallet. One is a web wallet, internet identity. It's called internet identity. So the address is here, identity.ico.ic0.app. So it also has another project, another third-party company. They develop something like MetaMask. It's a browser extension. It's called Plug Wallet. So when you do a development, you can by default you should choose internet identity to do your integration into your app. Second option, you can choose Plug Wallet. So if you use internet identity, so later I got some example for you. So you can see how to integrate the Dfinity internet identity SDK to perform the authentication. Plug Wallet, you need to visit the Plug Wallet website to see the integration process. So how internet identity work? So internet identity is a password. We call passwordless authentication. Nowadays, a lot of Google account, Facebook account, when you want to do login, right? So basically, you will need to enter your email and enter the password. But this is not hacker-proof all this. Basically, when you use the password that is too easy to guess, your account will be hacked by someone. So that there is a risk of password leaking. For using internet identity, it actually it can be work like open authentication. It can work like a Google account. It can work like a Facebook account for you to develop your website to use internet identity to perform authentication. Then this kind of mechanism, they are using some new technology called passkey. That means when the moment you create your internet identity, then it will prompt you to choose which device you want to store the passkey, because it will generate a random secret password called passkey. Then after that, it will come out a QR code, and then you need to use your smart device like your smartphone, Android phone or Apple. Then the phone scan the QR code, will turn on the Bluetooth, and your laptop also need to turn on the Bluetooth. There will be a synchronization happen. Then after that, the generated password from the laptop will transfer into the smart device and store it. After storing, then successfully, you will have the internet identity number. So it looks like something like that, 253 or 0. So you need to remember this number, because whenever you use a new device, all this to log in the internet identity, you need to key in back this number. Then it will follow back the same flow. Then you come out QR code. Then you use back the device which already using to store the passkey one to perform the authentication. So this number is very important. This number like your username. So what if, as I say just now, the passkey is going to store in your device. What if you lost your device, right? You have a few options protect your losing of your passkey. Number one, you can add passkey to multiple device. That means if you own multiple phone, you got two phone, basically you can add the passkey to multiple device. Or second option, you can use recovery method. That means this method will help you generate another 24 seed phrase, another seed phrase. You can use this seed phrase to recover back your internet identity. But this 24 seed phrase is not compatible. It's not compatible with the seed phrase you generate using the command line. It's not compatible. It's different. This seed phrase only for recovery of internet identity. You cannot use this seed phrase to restore into the DFX. So for end user integration, your DApp always will use internet identity or plug wallet. So I will skip this. Network nervous system. Basically, network nervous system is the system application, like a window application that deployed by ICP or Definitive Foundation. This is a DAO. It's a one. So nervous system, one of the core function is a DAO to govern the internet computer. Another one, they also provide you a default wallet of the internet identity. Just now, by using internet identity, basically you won't know your principal ID. You won't, because it is just authentication with this ID. You cannot see your principal ID under internet identity. You also cannot see your account ID under this internet identity. So you can visit the network nervous system, then sign in with internet identity. It will show you this internet identity has holding how many ICP, CKBTC, and CKETH. And from here, actually, you will able to access and retrieve the principal ID and account ID of this internet identity. Later, I also share you a code how you use the code to retrieve the principal ID or internet identity account ID of the log-on internet identity. So up to here, this is just nervous system. Okay, now come into a basic the development of ICP. So for other blockchain, when you develop a smart contract, you deploy, you get your smart contract address, then you can start using it. So by default, it will be the storage will be forever there. So in ICP, because the concept is more towards cloud solution or cloud service provider, compare like others is a purely smart contract. So in ICP, it has a concept called canister. So canister, you can imagine canister is similar to a container. So container will be concept of container like Docker, Kubernetes, all this. So ICP concept is whenever you want to deploy your smart contract, you have to prepare a canister. It's same to like you acquire or you subscribe to AWS, all this, the container services. You need to create a containers, then you use a command line to deploy or upload your code into the Docker, or because you need to create an image, Docker image, and upload into the container to subscribe from AWS. Same in ICP. Then whenever you build your application, all this, first you need to create a container, then you need to compile your code into the WebAssembly image and upload the WebAssembly image into the canister. Then canister will be activated and run and able to run your code. And how do ICP charge? Charge this kind of services? So the concept also similar like the cloud hosting provider. When you run your virtual machines, right? Every month the bill come out, you need to pay. To continue running your virtual machine or container because it has a fee, a hosting fee. Same to ICP, all the canister, you also need to pay a fee to run the canister, pay a fee. But the good thing is of ICP, they are using reverse gas model. So by using this method, actually is a project owner. The person who deploy the canister need to pay a fee, means need to prepare a fee into a canister. The fee currency called cycle. Prepare a fee, the cycle into the canister to keep the canister running. That means for those end user using your smart contract, calling your smart contract, do not require to pay any fee. So it is much more easier to onboard the current existing Web2 user, because basically they just need to use internet identity to create their first account. Then they can start interact with your smart contract or your application without need any fee to execute a transaction, compared to other blockchain, example Ethereum. End user, their wallet must have Ether to execute the transaction, as in ICP reverse gas model. That means you are the developer, you develop your application, you deploy your application into canister, then you need to buy the cycle and prepare the cycle into the canister to keep your application running inside the canister. So canister, you will need to pay with cycle. So cycle is the fee. And what is the price of cycle? Cycle, actually you can say it is a stable coin. You can say cycle is a stable coin or stable currency, which 1 trillion cycle worth equivalent to 1 HBR. HBR is a bucket of currency, which always equivalent approximate USD $1.32. Sometimes it's 33 cents, but you can say cycle is a stable currency, 1 trillion cycle. So that is the reason ICP charge this way. Instead you are using ICP to pay for this canister, because ICP coin or token is volatile. That means if it's volatile, by default, if you are using ICP to pay the fee, that means the fee can be fluctuate, sometimes very expensive, sometimes very cheap. But using cycle is more stable. Then those Web2 developer or Web2 user is more easier to understand the fee model. So how you buy the cycle? Later, I have the command line for you to know how to buy the cycle. So right now, to buy the cycle, is the only option is convert ICP into cycle. When ICP more expensive, you will get more cycle. When ICP the price go down, then when the moment you convert, you will get less cycle. So to start a development as in ICP, it also has the development network or local network. It allows you to start the local version of ICP blockchain for you to do the development. So actually, this is a command line how you start the local network, ICP local network. For your informations, compared to other blockchain like Ethereum, all these, they have testnet. Example like testnet, Sepolia, right? All other has testnet. Local net means you run the own nodes, and mainnet. In ICP, unfortunately, it doesn't have testnet. So when you do development, you will test it in your local, everything okay, then you deploy. You will deploy to mainnet. There is no testnet for ICP. So this is how you start your local version of ICP blockchain for you to do development. So once you start the local network first time and you run this, then ICP blockchain, the local network will automatically deposit or generate 100 trillion cycle in the local network. This cycle doesn't worth any money. because it is just inside your local network, but it will still simulate exactly like the mainnet. So you suppose you will have 100 trillion cycle, approximately it should be 99.9 trillions. So you will get your wallet. This is the cycle wallet. All the cycle must have a cycle wallet. All the cycle must have a cycle wallet to store. Cycle only able to store in canister. So cycle wallet is a canister with the cycle wallet code inside. So you run this, it will generate your cycle wallet in your local network. Then you run this, you will able to check the current cycle inside your cycle wallet. Then for mainnet, there is a few way to create your cycle wallet and deposit the cycle into the cycle wallet. It won't automatic generate the 100 trillion because this is only for local. For mainnet, you need to either use an ICP to convert, or you get a faucet, or you get the cycle coupon. You get the cycle coupon so that you're able to kickstart the first deployment into mainnet. Next. Okay. So once you attend this workshop, for those who need a cycle wallet, you can ask from me. Later of this slide, maybe I will give you a link of the feedback form. Please do sign up the feedback form, and once I got your email, I will able to send you the coupon code. Then you use this command line. With enter your coupon code. You will entitle with about 10 trillion cycle, which you can use this cycle to deploy your application into ICP mainnet. Once you use this way to redeem the free cycle, it will also automatically generate a cycle wallet for you and deposit the 10 trillion cycle into your cycle wallet. After that, you will use this command line to get the wallet ID. Remember, once you have your cycle wallet, please get your wallet ID and save it. Please back up your cycle wallet ID, because in case you change device, you recover back, and you're able to recover back all your account in another device, but the cycle wallet won't follow. You need to run another command line to link back the cycle wallet, and the moment you link, you must enter back your cycle wallet ID. So that's why you need to back up. This, and this get the cycle balance in the cycle wallet. So you always see this. You will see this parameter, right? When you don't have, if you enter without this parameter, when the moment you run your command line without this parameter, that means you are connected to the local network. If you enter with this parameter, dash network, that means you are connected to mainnet. So how you issue command or how you deploy your application, this parameter is important, whether you are interact with local network or mainnet. So always remember dash network IC. Okay. So for other than that, because maybe some others developer, they may not attend the workshop or anything. So they also want to kickstart the development, but they don't have the free cycle coupon. How do they have the cycle and create the cycle wallet? So this is a step. This is a step how they first create their cycle wallet, and how they top up the cycle into the cycle wallet. First, make sure your account has ICP. First, this account must have ICP token. Then you will run ledger create canister. First, create the canister. Later, install the Cycle wallet code and WebAssembly code into this canister. Then you will able to have the Cycle wallet. This is the method to create your first Cycle wallet. Then later on, you can use this command. Use this command to convert your ICP token into Cycle, convert into a Cycle and deposit the Cycle into canister ID or your wallet ID. So this is how you convert your ICP token or to Cycle. So this is a command. So other than that, there is a different command line. Then you can do some research by yourself. Okay. So these all others useful command. You can have this. Then these are references. I also give you some references that save your time to search around. I will compile this. You can have all the references in this page. Next. So this is the how you kickstart to create your first smart contract and deploy your canister. So by default, as I say, to develop smart contract or application in ICP, the backend programming language. That's what later I will tell you why I say backend programming language. So the backend programming language is by default is using Motoko programming language by default. Then it also support Rush programming. It also support Rush programming. And in beta, it support TypeScript and Python. Motoko is more easier to use compared to Rush. Unless you're already a Rush programmer, then you can start with Rush, because Rush programming, it can access more low-level function of ICP API. Okay, so we always deploy our application or test our application to create the first hello world. So this command line to start the local network, and use. So normally how we generate the project? How we generate the project? We just run dfx new your project name. Then ICP will this dfx will prepare a project structure. So if you want to create hello world, you type hello. So once you type hello, basically this tools will generate a sample hello world code for you. So it will ask you, always will ask you the backend language. What programming language you want to use for your backend? And then it will ask you again, what is your front-end framework? So front-end framework, I think nowadays most of the ICP are not the Web3 development for your front-end UI, UX, all this. I believe most of you also using React, or some of you may use Vue or others. So you can choose your front-end framework. So once you choose, then after that, there are several options. You can skip it. Basically, you just can skip it. Then you will see a folder with hello world is created. Then I will explain. Okay. So this is how ICP DApp architecture compared to others blockchain. Whenever you develop the DApp, right? Then the smart contract only handle we so-called the backend business logic. Example, you are using like ERC20 token. Those smart contract only able to handle the token transfer, ownership of tokens, balance of token, all is a backend data. And your front-end application, that means like if you are developing some like DEX, DeFi solution, you must have a website, right? But where you host a website? Normally, you will still use back the convention way, finding a hosting company. Then you use React or whatever's front-end framework. You build your front-end code. Then you get a hosting account or like subscribe to AWS. You will be upload all your front-end application, front-end code into those current hosting. And this means your application is not fully on chain. It's not fully on chain. But for ICP, it let you have an option. It let you has an option. Basically, actually, you can host the full website in ICP. So this is the architecture. So when the moment you create project, you say I want a front end. I need to have a front end and back end. So the architecture will be like that. So ICP will auto generate you a front end canister. Then the moment you build, it will bundle all the code and automatically upload into the front end canister. So front end canister, when the moment you deploy in the website, it will generate a web URL. It will generate a web URL for you. It will auto generate a web URL for you to run your website in the browser. So this is how front end canister work. And back end is very good for back end. All the smart contract you develop, all this, then you deploy into the back end canister. Basically, it will generate you a API endpoint. That means for a front end application can post data into the back end canister through the pre-generated API endpoint. Same, you can return retrieve the result also through the backend canister through the API endpoint generated by ICP blockchain. That means the whole transaction, everything can be automatically run inside the browser. So continue on. So how the structure look like in the Visual Studio Code? So you will always see if you choose to, but this is optional. That means you can generate a project purely smart contract without front end. It's optional whether you want to have your front end also host in ICP. If you choose this, the project structure, it will be always the project name underscore front end, another one underscore back end. So for underscore back end, it depends on programming language you choose. If you choose Motoko, then the file extension always .mo. Then in under the front end folder, you will see all your React code if you choose React. So this is how the project structure look like. So once your hello world, it's very easy to test it out. You just run dfx deploy, and it will build and it will compile and build and deploy, automatically create the canister and deploy the WebAssembly code into the canister. And you will always see the response. You're able to see the generated URL in the local host. So it will tell you the canister ID of your front end application. So when you open browser, you copy and paste this URL, so you will see your website. And you also has a we call Candy interface. Then this is your backend code. Then if you access through the Candy interface always is a auto-generated web interface to test for you to debug and troubleshoot your backend canister. It make your life easier because or else you need to use the Postman or whatever to test the API endpoint exposed from your backend canister. So without that, it's very difficult, right? So there is a Candy interface. So you just copy this and paste into the browser. Then you will see a auto-generated web interface for you to test all the public function of your smart contract. So you can test it for your deploy. And since I say just now, ICP has no testnet, correct? Has no testnet, but it gives you a playground. It gives you a playground environment. Playground environment actually is for you to deploy your canister into the ICP mainnet without paying any cycle. So, but your canister only able to run 20 minutes. So once the 20 minutes over, the ICP will shut down or bring down your canister. Bring down your canister. It will shut down and bring down. It's just like other hosting company. You didn't pay the bill, they will turn off your container. So to deploy into the playground method, you replace the dash network IC with dash playground. Once you deploy, then you will see success like this. Then you will see a URL like this. So whatever URL end with ICP0.io, all this, that means it's running in mainnet. That means you can copy you can copy this URL and paste it in the browser and run it. It's accessed via the default ICP web server. So other than use browser to test it with your backend canister, then you also can use command line. You can use command line like this, call your backend canister, the public function, and the parameter or argument, So you also can use CLI command line to test all your canister or your smart contract. So it has a several option for you. Okay, to deploy canister into the mainnet, as I say, just a different parameter. Deploy, you put in this parameter, network IC, it will deploy into the mainnet. Then from here, you can see that once you deploy success, you will see that there will be a web URL for you. You just click this URL, open browser, you can see your website. Actually, you can view your website, and if your website connect to the backend, then you can have certain interactions with your smart contract. Then they also show you the candid interface of your backend canister. It is called using the CLI canister mainnet, mainnet and call. Okay, so these are the command line. Basically, once you deploy the canister, sometimes you forgot your canister ID, you can use this command line. So all this is canister ID. You can see all this canister. You may forget your canister ID, then you can use this method to retrieve your canister ID, the front canister ID, your back canister IDs. Okay, this is another kind of important commands, because your on and off, you need to use this command to check whether your canister still have enough cycle. As I say just now, in ICP if you compare to other cloud service provider is a postpaid method. That means you run your virtual machine, you run your container first. By month end, the cloud service provider will come out a bill for you. Then you need to use credit card to make payments or whatever to make payment to settle the bill. For ICP, because it's a decentralized, there is no organization to issue you invoice or whatever. So the method is prepaid. That means the moment you deploy your canister or the canister, basically by default it will transfer some of the cycle into your canister, and run it and active it. So time by time, the ICP network will consume and burn the cycle within your canister. So you can check, you can see the balance there, right? You can check. If this cycle go low and become 0, then ICP network will shut down your canister. Shut down your canister means if your canister is front end, you click the URL, you won't able to see your website anymore. It will bring down your canister. So you need to know, you need to time by time to check whether the cycle balance in the canister it still has enough cycle or not. Every call is the same. Every call to your front end canister, example, every call to your front end canister, someone visit your website, it will consume cycle. Whether it is sending data in or sending data out, or even the canister within the canister can communicate. Means you may deploy multiple canister. Each canister can talk to each other. Then it will also consume. It will also consume cycle. It's just like how our cloud service provider work. They got ingress bandwidth, outgress bandwidth, CPU usage, all this. Yes, it will cause cycle. It will burn the cycle. ICP network will burn the cycle in your canister. Even like the data you store in the canister, you occupy the storage. Yes, it will burn the cycle. But the good thing is you may deploy. Example, you may test your development, deploy your application, your D app into mainnet. But after that, you want to turn it off, means you say, oh, I no longer need this canister running. You can shut down it, you can turn it off, you can delete it. Once you delete your canister, the remaining cycle in the canister will automatically return back to your cycle wallet, so you won't burn the remaining cycle. So there is some specification of a canister. Compared to others blockchain, same. Compared to other blockchains, it has something different. Canister, as I say, it works like a container. That means in ICP, the canister looks like you can assume like a laptop, like a PC, like a computers. It has a specification. A canister let you has access to something called heap memory. Heap memory work like RAM. A canister let you access to 4 gig heap memory, means something like 4 gig RAM. And it also let you access to 400 gig stable memory. The meaning of stable memory, you can treat it like your hard disk. So you can assume one canister can let you access to 4 gig RAM and 400 gig hard disk. Stable memory or stable storage or stable variables. Why it has something like that? Later I will show you what is stable memory and what is heap memory. So in ICP, it actually works like a virtual machine or container. When you run your application, you deploy your application. Within your application, you will have variable declaration of variable, like some variable like that. You declare variable, all this. By default, those variables are in heap memory. What it means, those variables, the storage are in heap memory. ICP, the canister, always by default is upgradable, not like other smart contract, which you need to purposely deploy your smart contract with upgradable features. Then you only can upgrade the smart contract. But ICP don't need. By default, it is automatically upgradable. The upgradable, just like how your mobile phone update the new version. That means if you deploy a new version in your Google Play Store automatically push the new version into the mobile phone then you will have a latest version of application. Same. So you just need to execute the command line to perform the upgrade. So when you develop the application, you need to really focus and handle how your storage. You will declare your variable, all this is not a stable memory, is inside a heap memory, it may cause problem. The problem that means when the moment, especially when the moment you upgrade your canister, because the flow of canister when you do upgrade, first you deploy your code, the canister is up and running. Then the moment you perform the upgrade, internally it will stop the canister. This will cause problem when the moment canister stop, whatever variables, all these variables that you declare, if without declare as a stable, it will just like RAM. It will return back to the original state. It will, like example, this value becomes 100. If you perform upgrade or you stop the canister, actually the value back to 0, and you run again, you will get the value equal to 0, not 100. Not like other smart contract, all this, when you update the variable, basically is permanent there. It's permanent there. No, in ICP, you need to have specific example like stable. If you specify a variable with a stable word in front, for example, once you stop the canister and you upgrade, load the new code, then you run the canister again, the value will persist because you declare as stable. That means like you store this value into a database, into the hard disk. So this is something a bit special. So there is a stable memory, stable storage, and non-stable in ICP. So this is an example how you do the canister upgrade. Like example, you build this code value, right? Build this code, you change the code, then you deploy, then you test it, then you change the value, all this, then you perform and you stop. First you stop, you change the code, you build, you install the new code, and you deploy the new code, then you will see the new function. So this is a step how you do the canister upgrade. So that is all the basic how you kickstart the development, And others very special feature about ICP, which number one, I can say that it has a built-in Oracle service. Compared to others blockchain, you need a third-party provider to provide Oracle services, which you need to call their smart contract, send the web API, URL, all this, pay the fee. Then later on, they will call your smart contract callback function, and return you the result. This is how normal Oracle services work. But for ICP, it has something very interesting. It called HTTPS outcall. HTTPS outcall, that means it built in a HTTP request function built in. It work like, if you are familiar with JavaScript, all this, it work like similar like a fetch function or AJAX call. It can perform a AJAX call or inside the smart contract. HTTP out. So that means when you build a smart contract, basically you do not worry about who provide you Oracle services. You just as simple as you just put your web URL, your API URL, just run like that. HTTP_request, run it. Then the smart contract immediate will call the external website and retrieve the result back. Then your smart contract will have the external world data without need any third-party Oracle services. Means with this method, means it also allow you to connect to other blockchain JSON RPC, because you can perform a direct connect to any of the blockchain to retrieve the blockchain transaction or submit transaction to other blockchain. It make it so easy for you to build a trustless bridge to other blockchain. And with the security come from ICP blockchain. You do not need to maintain your security, private key, all those, because all provided by ICP itself. So this one of that is HTTP out call. Then in ICP, it also has a ICP token standard. ICP token standard. Same like ERC20, all this. So ICP has a first version of token standard called ICRC1. Then after that, they extend it to ICRC2. This is a fungible token standard. ICRC7 is non-fungible token standard NFT. Extension, ICRC37. So you can have a reference for more detail. Okay, just now, as I say, you have a HTTP out call. There I say you have a HTTP out call. That means you can connect to any external world, external website, even any blockchain JSON RPC, any JSON RPC. Then ICP also come out another feature called chain fusion. Chain fusion, that means you can connect to any blockchain JSON RPC. Second, how you sign the transaction. How do you sign the transaction? Because signing transaction required generate a key pair, public-private key pair compatible to that blockchain. Example, EVM, right? ICP has a built-in function, for you to generate the destination blockchain. Example, EVM key pair inside the smart contract, using ICP chain fusion system smart contract to generate EVM wallet. And you can use this built-in smart contract function to sign any EVM transaction and send the transaction to the EVM chain. EVM chain, that means Ethereum's, Avalanche, Arbitrum's, all kind of EVM chain it can sign. And it controlled by only your ICP account. It controlled by only your ICP account. So all the key pair automatically managed by ICP blockchain. And the blockchain, the private key, all this is stored in, encrypted and stored in several different nodes, which ICP itself also cannot retrieve back the actual private key. So you can study furthermore the architecture, all this. How the sign, basically, they has a technology called threshold signing. How to use a smart contract to sign the EVM blockchain. And actually, for this chain fusion technology, ICP basically can connect to many non-EVM chain also, like Aptos, RV, Bitcoin, Cardano, Cosmos, Dogecoin, plenty of non-EVM chain, or even the Toncoin. You can use ICP smart contract way to send transaction to different multiple blockchain. So it is so easy for you to build a trustless contract services, decentralized borrower protocol, because it's by native, I will say it's a native bridge is ready for you to use. So this is what I call chain fusion. Okay, so this is the okay. So the comeback is a lot of online learning. Okay, next I will share you some sample code. Go through some sample code with you. Let me share another. But this is a basics one. Let me cheating. Give me a moment. I will share you. I will share another. Another slide. Another slide.
Are you sharing on the Telegram group?
The just try. Actually, I already shared the code. You can fork the sample code. Share. Right.
Okay, I'll take
slide.
it from the slides.
Yeah, I got another slide, and I also got the codes. Okay, this is another slide. Okay. It's wrong. No. Yes. Are you seeing this slide, right?
Yes, yes, yes.
Codefest workshop, right? Yeah, because I'm not sure which slide you are seeing. Are you seeing the code? Are you all seeing the Codefest? Okay,
Yeah, yeah.
correct. Yeah.
It's a
okay.
new one. Yeah.
Yeah, it's a new one. Okay, okay. K Codefest. Okay, this is another. Actually, in the Telegram group, I also put in this URL. You can fork this code. This has some more code that for you to kickstart, because I provide you a few sample code. All this, how you do the internet identity integration, internet identity integration, and how you use the asset management function, internet identity integration. Then there's a link. There's a link to explain how to do the integration. Later, I will go through the code one by one. Let me open the GitHub. Okay, so internet, then it has, because I summarize all the different place the code into one sample code for you, easier to refer to. So in case you want to do some development, you can refer to my sample code. But my sample code is using React. You may use other method to do the web development, but my sample is using React. But I believe most of you are using React. So asset canister integration, HTTP outcall sample, and token standard sample. Okay, so let me bring up the code for you. Okay, share another GitHub and explain how my code works. Okay. Okay, you all can see the GitHub code, right? Okay, let me open this. So I will try. Never mind. Okay. So my structure is a bit spaghetti because I experiment it without using the command line to build the project structure. Without means I will try the different methods. Just if you are using a DFX new to create, basically it will have a workspace of front end and back end. Because I try with the create the front end first, then after that I will try manually insert the back end code. So that's why you will see the structure a bit difference compared to if you generate by using DFX new. So always if you want to deploy any code, you always want to build project, even like front end, back end, by using for ICP. One of the importance configuration file is called DFX JSON. If you use that DFX command line CLI to create, it will always generate a DFX JSON. So I will try to explain how this file structure, so that when the moment you build, you were able to success to build. So inside this is how its structure. So it has a canister section. Then if you want to do testing with internet identity, you need to deploy the internet identity canister in the local network. If you want to build your application that integrate with internet identity. So this is one of the sample command line. You put this, that means your project will have the internet identity installed in your local network. If you don't have that, that means there is no internet identity application run in your local network. So this canister, you tell when you build, you tell the DFX install the internet identity in your local network. Then this is the front end. This is the front end canister. This is front end canister. That means when you use React, you build your code. Normally, it will store in the distribution folder. So it will tell the DFX tools to take all your HTML code, the compiled HTML asset, upload into the front end canister. Front end canister, we also call it as asset canister. So we take all this story. So that's why the type is asset. Type asset means you ask ICP to deploy a front end canister. Then this is another type of canister, ICRC ledger canister. To deploy a token in ICP blockchain, you not like Ethereum, you need to take the ERC20 smart contract and modify it. The token, you already have the WebAssembly. You already have a pre-built WebAssembly for your token. So basically, you just need to install this canister and use this ledger canister. To create your token. You do not need to write your ICRC1 smart contract. You just need to take this canister and create your token. Then this is your own backend. This is your own smart contract canister. So that's why the type is Motoko. So this is how it's structured, the effects. Then my front end project is using Tailwind. Why all this later you yourself can refer to. So this explain the importance thing. Okay, how you first let me actually how you integrate internet identity into your front end code. You can go to the source. Okay, you can refer to this part. You can go to the use. Okay, first you need to have this JavaScript authentication client. You need to have this. You need to import this. Then you see how do I perform the login. Okay, then you need to set up the configuration for internet identity. This is default option. And this is important because this is to detect whether you are testing the internet identity run in the local network or run in the mainnet. So you need to choose the endpoint. This is a detection. It will detect if like this. If it detect the DFN network IC, that means your front end is run in ICP, mainnet. Then you need to use this. You are connect to the production, the production internet identity, or else you are connect to the local internet identity installed in your local network. So the default option. Okay. Use effect, all this. Okay. When the moment your website loading, so first you initiate the instance of the authentication client. So passing the option in, then you have the client instance, the authentication client instance. Okay. So when the website perform a login, you need to detect whether it's already authenticated. So this is a function to check whether it's already authenticated, means already logged in or not, right? If already logged in, yes. So if already logged in with internet, already connect with internet and log in. So this is a function how you get your internet identity principal ID. Or else, if you've not logged in, not authenticated, perform login, then just call like this. Login. Then when you call this function, basically the browser will redirect to internet identity. It's just like how you integrate Facebook login, all this. It will redirect to internet identity. Then and the user will perform the login mechanism, like scan the QR code, all this success, it will redirect back. So redirect back, then it will be success. Then you already success login. Then you will continue on to retrieve whatever necessary information from the log-on internet identity. So there's a how. So as I say, you can use this function to get your principal ID, then use this method to convert principal ID into account ID. Convert principal ID into account ID. So this is some of the code so you can refer to. So I give you a sample how you connect to internet identity, how you log in, how you retrieve the principal ID, and how you retrieve the account ID. So all under the use of client. Another main function will be in dashboard. Yeah, because it's a lot of thing using. Yeah. So import from the. So you can see import from the use of. So the hook from use of client. Okay. So I already give you a sample. So you can refer to this is it much more easier that you can start the integration of internet identity and how you retrieve the principal ID and account ID. I will give you all this code. And the next is asset manager. What is asset manager? I share another. Okay. Let me share. Asset canister, or we call asset manager. All the front end canister is asset canister. So asset canister, other than just hosting your website, basically it also has a storage for you for the end user, for you to upload file, upload your file. You can use it as a canister. You can use it as like a file storage. Means you can build your front end, then you can put an upload button. You can put an upload button and upload file and store the file, upload the file and store inside the asset canister, which is considered a front end canister. So that is all front end canister is a asset canister, and you can perform file upload. So my code also have a okay, let me back to my code. Okay, so how to initiate the asset manager instance. So you need to have this asset manager instance. How you connect to the authentication client. First, you need to log in internet identity. Then so you see, okay, once you connect, you got your internet identity connected, you got this, but then you need to create an agent. It's so-called the agent. So you go to the setup agent. So you go to setup agent, you get identity. So it's a HTTP agent. And this time you also need to determines where is your ICP, API endpoint, whether it's a mainnet ICP API endpoint or local. So local, you need to check the local JSON RPC endpoint, or this is a mainnet. This is a local, which port they are listen. So by using this environment variable, you can detect so that your HTTP agent will connect to the correct ICP blockchain API endpoint. Then you will have, and if you connect to the local ICP blockchain, you need to perform an extra step, which called fetch root key. You need to perform this extra step for the local, if you connect to the local ICP blockchain. Okay, that's all. Then you have your HTTP agent initiate. So once you have your HTTP agent initiate, set up then you need to create the instance of asset manager. Yeah, set up, you have your asset manager. So the canister ID is your front end canister ID. Your front end canister ID is the asset canister. So you have your asset manager instance. Okay. Then all those is prepared. And I have already the code how you use this asset manager to upload the file. Into this canister. Means you use your front end canister as the web storage to store your file. See, when click upload, handle upload file, so means you choose the image file. Then from the asset manager batch, so you also can choose multiple file. Then it can use a batch upload. Use the batch upload to upload the file one by one. So this is just a sample. batch. So selected file, convert into the array and start upload. Then commit. Then this is a flow how you upload the file into your asset, your front end canister or asset canister. So it gives you an option. So now you can see it gives you option. You can build. Actually, you can build a web storage, any like album or whatever into ICP on chain. That means ICP can perform like something like IPFX. You can upload files, all this. So this is a asset manager function. And next, you can look at, and next we are talking about the how you deploy your token. How you deploy your token. So you can refer to demo sh. How you deploy your token. That's why in the DFX I already put a canister required a CRC1 ledger canister. So this is the command line. Who can mint extra token? Who is the owner of this token canister? Yeah, so this is a command deploy all this ledger canister. Your token symbol, your token name, minting account, minter, or is principal ID. Remember using your principal ID. The transfer fee, you can charge transfer fee. That means the token transfer between different wallet, you can charge a transfer fee extra. Then initial balance, it can be a vector. Initial balance is which wallet has how much, which wallet has how much, all this. So this is a command line to deploy. So there is no coding required to develop the ICRC1 token. After that, you can use this to check the balance of the ICRC token. So it's a kind of simple for you to deploy the token in ICP blockchain. Then how to interact with the token by using your backend smart contract. Let me show you. Because you have a token already, you can develop a smart contract to perform something like DeFi or whatever to use to call the token, transfer the token, right? To mint the token from the smart contract. Okay, now is the time you need to check the backend code. You need to check the backend code. Types. So there's a template types. So the types, this is not related to token. Okay, for token, if you want to talk to your token, all this, you need to import, like Motoko, you need to import the token, your canister, your ICRC canister. So let me explain something. Okay, compared to others, before I talk about the ICRC canister. So this is some of the structure of the smart contract. This is one of the sample of the smart contract, which how you detect. If you structure this way, you're able to detect who deployed the canister. Install means you bracket this any variable, so it will tell you who deployed the canister. You are able to access who deployed, and this is a constructor variable. So you can pass any variable when the moment you deploy the canister. So this represent the current canister. So this variable or this. Okay. So from here you can see from here you will know that the installer, that means who deployed this canister. Argument is some Okay, someone is here. So you get the constructor parameter. Next is, okay, like if you want to know which account, which connector account, example, you log in with internet identity, then the internet, that account calling your backend smart contract, you want to know which account is, which logon account is calling your backend smart contract function. So you need to have a share message like that. It's same like Ethereum smart contract, all this message dot sender, but you use caller. So you know who is calling. But you also, if you don't put a bracket message, right? Then that means you do not need to know who is calling. Return the principal of the caller of this method. So you always deal with principal ID. So this will return the, it will return the canister ID. It's the same. These two is the same. And some of the other sample of the smart, you can use this function to check your smart contract, your current canister still have how many cycle balance. And it will also has other sample code how you transfer the cycle between the canister. But this I just give you a sample. Okay, this come into the important parts. How you interact with your token. Just now you deploy your token smart. You deploy your ICRC1 token already, right? Then normally how you interact with the token in your smart contract. So just now you already import this. Then actually it's just very straightforward. Like transfer, you need to refer some ICRC method. All this is one of the example. You passing in the transfer argument, memo, now, amount, sub account. You do not need a sub account because you are transfer. This transfer function is transfer token from this canister to another principal ID. Then what is the amount? The transfer result. So you call the standard ICRC1 interface transfer. So this is the result you get. So this is how use smart contract to talk to other token, the ICP token. Okay. Another, okay, here is a sample. Here this is a sample of HTTP out call. How you call the external HTTP out call. This is a sample function in the ICP smart contract. How the smart contract call the external word. So this is sample code. All this, like example, I call the postman echo. I put the URL there, request header, right? Then there's some transform of the context, means whatever respond, it will automatically transform the response body into the different forms. Then this is how you start the request. You prepare the request header, URL, all this, just like how you prepare the AJAX call. Okay, every HTTP call, you need to use a cycle and deposit a cycle to execute the HTTP request call. Because all the HTTP request call consume cycle. So you need to prepare some cycle to execute that, or else the HTTP request call will fail. So once you HTTP request call, then you will get the response. Then from the response, you convert back into the text form, or else is in bytes form, NATA. You convert back. then you can return back the decoded text for you to continue. So your front end can capture this. Front end basically you can capture this. So this is how to do the HTTP out call in the smart contract. Okay, how the front end integrate with the smart contract? Just now you already connected, right? So just now you already connected. You have the asset manager. You have the agent. Then, example, I already built my own backend smart contract, right? How the front end talk to the backend smart contract? What are the steps we need to do? Dashboard. Okay, it's here. Okay, first, whenever you build, right? Whenever you build, basically you deploy you have a backend smart contract, it will always automatically generate the header file. We call a JavaScript header file for you to import. Declaration. So backend. So normally you will import this file. Click. You will also create the instance, something like that. This one of the option. Or you can refer to the code to write yourself, also can. See, update client. Okay. So this is my method to connect the agent, initiate the agent, connect the agent with my smart contract to my backend canister. So that's why I put in the backend canister ID, which agent I'm using. Then that means I already enable the backend canister instance in my front end. So something like that, JT backend. Then how to use it. So once you have this done, okay. Just now my backend can retrieve the canister ID, installer ID, right? So once I already initiate to link my instances, my backend instances with the agent, straight away it's very simple. I just try backend call .id. It's just like how we use the web3.js to tag, then I retrieve. So you see how easy to connect your front end to the back end canister. Let me see. Okay. So actually this is just try. I think it's still running. Okay. So this is an example. I'll log in. Okay, log out. Let's see. Let me share the demo. How my code looks like when running. So actually this is the sample code, how it look like when running. So it's go into the local internet identity. First time run, you click. We got already run, so you already have. So click. Oh, you don't see. Never mind. Never mind. So access, you were able to retrieve the internet identity, principal ID, account ID, the front end canister ID. Then you can upload the file. So you to test upload. One upload, you were able to list the file, the upload file in the canister, in the asset canister or front canister. Then you can use the retrieve the backend call. Yeah, this is all the function from the backend smart contract. So this is what I cover. At least your end can start to have an idea how to develop the front end and back end, how to integrate together. So I think that's all for my sections. So hope all of you get something. So in case you have some question on this, please do drop your question in the telegrams.
Yeah, and the Telegram group link is already pinned here in the chat, right?
Yeah.
So
So later
everyone,
I will
yeah,
send a feedback form. Later I will send a feedback form. Then
yeah,
hope you all give me the email all this. Then I will let me know that you need a free cycle when the
yeah.
moment you want to deploy into the mainnet.
And plus, like, we will be sharing the recording as well, right? So that you guys, because it was a long session, so I can understand there will be moments where the concentration is not here, right? So we will be sending out this recording by tomorrow maximum, right? So that you guys can able to see this, right? Francis, is there anything left, or are we done with the workshop?
No, that's all. This is all I cover.
Thank you so much for, like, providing your guidance, right? It was really amazing how detailed this workshop was, right? And I'm pretty sure if somebody was following you from the starting, right, it is a vast knowledge experience that someone was gaining, right? Thank you so much for providing your expertise and time, right? Please, everyone, in the chat box, we have dropped the Telegram group link. Please join that, right? Because there you can directly get in touch with Francis, right?
Yep.
Not
Yes.
every single day you'll get to interact with, like, a developer of his stature, right? So that is one thing, right? Thank you so much, Francis, and thank you
Yeah.
everyone for
Okay.
joining
Thanks.
in, right?
Yeah.
Let's end this and join the on Telegram.
Yeah. Hope to see
Thank
everyone
you.
deploy. Have a fantastic journey
Thank
in
you.
the hackathon and deploy your fantastic app to participate into this hackathon. Hope
Yeah,
my session
absolutely.
helped you. Okay.
Absolutely. Thank you so much.
Okay. Thank you so much. Bye.